Planets which revolve around our star, the Sun, are known as planets, but planets which revolve around other stars are known as exoplanets. We can also say exoplanets are the planets outside the solar system. In this video, you will get to know how these tiny little exoplanets, which are by the way very far away from us, are discovered. Just try to imagine what I'm going to say next. If you place a huge bright star next to a tiny dim planet, what do you think? Will you be able to see that planet from far away? Obviously no. It's like looking at a small honeybee from another country. Now obviously looking at these exoplanets is not easy. So scientists have come up with some amazing jugaadu ways to discover these exoplanets. Number 1, the wobble effect. We all know about the effect the gravitational field has on two objects. Due to gravity, both of them are attracted towards each other. The level of attraction depends on the mass of these objects. The object which is smaller in size will experience a greater pull towards the object with larger mass. This is why we see planets revolve around the Sun and not the Sun revolving around the planets. But even the Sun, which is of greater mass than the planet, is slightly attracted towards these planets. So in reality, this is how the revolution of planets looks like. By observing the movement of the star, we can figure out if there is any exoplanet which is revolving around it. This is known as wobble. And this is how the wobbling of the star looks from far away. But there is one slight problem in this method. This wobbling of star is so little and so minute that it is very difficult to observe from naked eyes. So we use different indirect methods to figure out if the star is wobbling or not. Now there are two ways in which we can figure this out. One way is using the knowledge of the Doppler effect. If you don't know about the Doppler effect, I've explained it in one of my previous videos, you can check out there. Here, I'm giving a quick revision of the Doppler effect. If any object moves away from us or closer to us, it appears to be in a different color. The second method is astrometry. In this method, we measure the relative distance between the main star and the other neighboring stars. If the distance keeps on changing, we can make out that the main star is experiencing a wobble. Number 2, looking for transits or shadows. When a planet comes in front of a bright star, it blocks some of the star's light. This is what we observe when we look at the star. The brightness of the star decreases for some time periodically. This gives us an idea of the presence of an exoplanet around the star which is blocking its light again and again. Number 3, directly taking pictures of exoplanets. Now this might sound a bit confusing to you because in the beginning I've already mentioned that it's very difficult to look at these exoplanets directly which are at such far distances from the Earth. So what does this direct imaging mean? What we do in this method is we block the glare of the bright star which is next to the exoplanet. It's like using sunglasses on a bright sunny day to see things clearly. Number 4, gravitational microlensing. Firstly, let me tell you for a fact that gravity bends light. When light passes through an object with huge mass like a black hole or a massive star, it bends and changes its direction. Now look, this is the main host star around which an exoplanet revolves. Let's keep the exoplanet aside for a while. There is another star or a secondary star, we can say, even further away from the main star. We will observe the light coming from the second star. When the light is directly coming from the secondary star, we'll see that the star has some amount of brightness. But when the host star passes from in front of the secondary star, it bends the light coming from the secondary star. This light is focused at a point on Earth. This drastically increases the brightness of the secondary star. This is very easy to understand. It's like using a lens to focus all of the light at one single point, and that point will be very bright. This is known as the lensing effect of the host star. When we add the exoplanet to the mix, the same thing happens as before. But now, along with the lensing effect of the host star, there is a lensing effect of the exoplanet as well. Which means this time there is one more slight increase in the brightness of the secondary star due to the bending of light around the exoplanet. But this effect, which is the lensing effect of the exoplanet, is very small and for a very short period of time as compared to that of the host star. This small but sharp increase in brightness proves the presence of an exoplanet around the main or the host star. These are some indirect ways in which we manage to look out for those tiny little exoplanets. Obviously, not all of these methods are foolproof. So, scientists use more than one method to confirm the presence of an exoplanet. So far, more than 4,000 exoplanets have been confirmed, and there are so many more in the waiting list. This is it for today. Hope you found this information useful and interesting. Please like this video, watch my other similar videos, and subscribe to Cosmic Strip. And follow Cosmic Strip on Instagram as well. Thanks for watching.